In this lesson, we're going to review solving systems of equations by solving 4 sample problems. I encourage you to stop the video after you've seen a problem, try to solve it yourself, then start up the video and see how you did. In our first problem, we have 2 equations that are both solved for y, so they're written in slope-intercept form. So they can be solved quickly by graphing. And the first thing I'm going to do is identify the y-intercept on the first equation. That's 7, so I graph it. Then I identify the slope on the first equation, 3/5. So from my y-intercept, I travel 3 up and 5 to the right. Graph the point, connect the 2 points. I've graphed the first equation. The second equation, I have to be careful. I have -9. I remember that a -9 makes the y-intercept -9, so I graph that. And then I have the opposite of x, and I know that that means that the slope is -1. And if the slope is -1, you can go 1 up and 1 to the left. And I do that. From my y-intercept, I connect my 2 points, and I now have the second equation graphed. And I can see that these 2 equations intersect. My job then is to identify the coordinates of the point of intersection. I have the coordinates are -10 for x and 1 for y, and I've solved this system of equations using graphing. Now here's a system. One is in standard form, one is in slope-intercept form. But the one in slope-intercept form also means it's solved for y. So substitution is a good way to go. We take the expression for y in the second equation and substitute it in for y in the first equation, which gives us this. And that leads to this. And again, I like to change my subtractions to adding the opposite to avoid sign errors. I'm applying the distributive property next to get the 2x plus 9x plus 21 equals -12. I combine like terms, and I also add -21 to both sides, and I get 11x equals -33. Divide both sides by 11, I get that x is equal to -3. I take that -3, I substitute it in the other equation for x, and you'll notice I've rewritten the other equation down at the bottom, and I've also pointed where I'm going to substitute the -3 in for x. That gives me -3 times -3 take away 7, which is 9 take away 7, or 2. And I ran out of room, so I wrote it on the side, y equals 2. My solution then for this system of equations is -3 and 2. Here's a system, both written in standard form, and we have a subtract 3y on the left and an add 3y on the right. So we're going to use linear combination. We're going to take the equation on the right and write it underneath the equation on the left. For convenience, I change the subtract 3y to add -3y. I combine these two by adding, and the -3y and the positive 3y are opposites, so I use a shortcut and cross them out, giving me 8x is equal to 48. Divide both sides by 8. X is 6. And then I take the 6 and I substitute it into the other equation, and I get the 3 times 6 plus 3y is 28. 18 plus 3y is 28. I add -18 to both sides, and I get 3y is equal to 10. Divide both sides by 3. It's not an integer. There's no rule that says all answers have to be integers. So my solution for this system is that x is 6 and y equals 3 1/3, or written it the way I wrote it, 3.3 repeating. In our final system, we have 2 more equations in standard form. Not quite as easy to work with as the first one because we don't have any pairs of opposites. And in fact, if we look at the 6x and the 9x, the lowest common multiple is 18. And if we look at the 8y and the 10y, the lowest common multiple is 40. So I'm going to use the smallest one, the 18. So that means I'm going to multiply the first equation by 3 so that I end up with 18x. And I'm going to multiply the second equation by -2, so I'll end up with -18x. There's my work on the first equation. There's my work on the second equation. I can now write the second equation underneath the first equation, and you can see the x terms are opposites, so they're going to go away. And when we add 24y plus -20y, we get 4y, and of course 12 plus -14 is -2. We divide both sides by 4, we get y is equal to -1/2, which I've written as a decimal, -0.5. We're going to substitute that back after we've brought one equation down to where we have a little more white space, now we can see that where we're going to substitute the negative 0.5 in for y, we get that 6x plus 8 times negative 0.5 equals 4. We do the arithmetic, we get 6x plus negative 4 is 4. We add 4 to both sides, we get 6x is equal to 8. Divide both sides by 8, and we get that x is equal to 1 1/3, which I've written as 1.3 repeating. And there's my solution. X is negative 0.5, y is 1.3 repeating, and we've solved this system of equations using linear combination.